All right, we are going to cover pond and pit survey estimate volumes. So there's a lot of times you're out there at a pond or a pit and the customer is there or probably has requested that they need a volume ASAP. This happens all the time. And for whatever reason, maybe Ryan or myself may not be right there at the computer ready to crunch those numbers and crank out a volume. It is very handy to know how to do this yourself. So what we're going to do is we're going to go over how to do it real fast. So I am looking at a survey file that Roy sent me yesterday. So you can see here weekspond.som. SOM is the standard survey file that we use on anything that's basically non-Z boat. So 99% chance this is going to be the file format you're working with. So you've already got this if you just did the survey. This shows here 401 kilobytes. That's a telltale sign about whether or not it's good or bad. It won't necessarily tell you that it's good data, but if you see a 1 kilobyte or 10 kilobyte, there's a pretty strong chance that that's a bad file or bad data. So you probably need to redo that. Anyway, so let's jump into it here. I've already got this Weeks Pond survey file saved to the Swift Energy folder in my pond survey folder, and so basically it's all categorized. Everyone probably does it differently, but it's important to kind of keep this stuff broken down by customer and then by lease because we do so many that being organized makes this process a lot easier. So I've got it saved. Let's jump into Sonar Vista. This is the first program you need. If you don't have it, let me know. I'll get it to you. I'm not going to go into any real in-depth settings, major modifications. We are going to assume that this is a clean survey and all they really need is a ballpark figure. So open this up. We're going to go to import SonarMite. Sorry, I was almost clicking on the wrong thing. Import SonarMite, and it's going to pull this up because I'd already opened it up. But if you hadn't, you know how to navigate through your folders. Anyway, well, if you didn't, I'll show you. Here it is. Open. This is what you're going to see. It always asks you to click it OK a couple times. Got to re-register. What we're looking at, this upper window here shows kind of a topographical view, as if you were looking right down on it from above. This outside perimeter is the border of the pond. You see we got good east-west passes here, solid northwest, north-south passes, and a good perimeter. Now, one thing you note, just like any time that I ask you guys to send us survey files, make sure to notate anything irregular about the pond, dense vegetation on the east side, super shallow perimeter on the north side, maybe like a 50-foot span of 1 foot water you just couldn't get into. In this particular case, Roy had told us that there was a large gathering of trees that kind of blocked him from making a good perimeter. He didn't tell me which side it was on, but I can tell you right here, just at looking at this north, this east, the south side, nice smooth perimeter. And then you get in here, and this looks very irregular. So I'm willing to bet that that's where these trees were, and we will be able to kind of verify that whenever we open the map within the next program we're going to use. So this one, this all looks pretty good. Down here on the bottom window, this is kind of this is a view that logs depth over time. So basically here on the left is when he started, and each peak and valley here represents depth from when he started to when he finished. So this all looks good. There's a couple blank spots here that might represent some bad data, and there's some really high and low outliers that also might indicate some bad data, but by and large this looks pretty good. I don't think there's going to be a problem here. The only thing we do in the software that we do now, the guys doing the reports, the final report that we give back to the customer, they're going to go in here and they're going to clean this up a little bit more than we do. That's pretty much. Uh, I mean, it's mostly aesthetic. There is a little bit of practical reasons why they do that, but it's not anything that we need to get into. I have experimented with it on both ends, making a really clean one and then making a really quick and dirty one like we're doing here, and the percentage difference is really pretty small. And like I said, this we only present this as a rough estimate to the customer. Don't ever, you know, swear your life by this number you give them if you're going to do it this way. This is just to tide them over, if you will, and it'll be just a couple more days until they're ready. I didn't even explain what I just did there. What a goofball. I went in here under the edit filter range. It helps if I explain what I'm doing. And all we do is we change this this Z max value to negative 0.01. You hit OK. And it didn't really change because I'd already done it. I just didn't explain what I was doing. Basically what that tells it to do is anything on that Z-axis, remove data that is less than 0.01. Basically all the zeros. For whatever reason, bad data is typically zeros, either really high numbers or nothing. So that kind of removes, that's like a quick, clean sweep of bad data. It doesn't take out everything, but it cleans it up some. As you can see here, all those kind of stray lines are gone. Now we want to export this. Go to export, simple, XYZ, and you want to put it in your weeks folder just like your SOM file, and just name it weeks, Swift weeks. Name it something that's going to let you know what it is. Keep all those boxes checked and click OK. And we're done with Sonar Vista. That's it. Now we want to open up HydroMagic. HydroMagic, there it is. And this program requires a little bit of setting up on the front end the first time you use it. I'm not going to go into that on this video. You've got to kind of go in and make sure there's just some settings you want to get locked into place before you do this. I'm not going to do that now. This is just a rough estimate video. I'm going to make another video or a little write-up for just getting those settings all where you want them. So once you're in HydroMagic, go to import, import ASCII data. Do you want to add maps to the project, blah, blah, blah. Hit yes. This is what you want to do. This is some of the settings that it's going to ask you. You can pause this and see what it's set to if you don't want to watch the other video. United States and 02919 Texas South Central. Okay, this is something you will have to change every time. There's not a lot of steps, but this is one of them where you got to pay attention. This first data file box, this is asking, okay, what file are you wanting to use? And what you're wanting is that XYZ file you just created in Sonar Vista. So hit browse. Here's the weeks.xyz we just saved. Open. Load data as sounding. Once this is set, you don't have to change it. You don't need to change the field separator, the number of lines, the number of fields. You do need to change the coordinate field order. You want that to be in longitude and latitude. You don't need to change the coordinate field format. The projection in units, hit select, and check this top radio button here. Map is not projected, coordinates are in latitude and longitude. So we want to get out of the northing and easting. Hit OK. And the depth data and the file is in meters. The handheld, the Archer that we use in the Sonar Vista program, saves it in meters. So we need to tell it that that's what it needs to read it in. Click OK. More often than not, you'll click OK and you will see nothing. It did work. You just have to go over here to the right hand side, this Project Explorer box, and basically what we just did, we just we just imported a sounding. That's basically what we created there with the survey, and then we use this. I'm sorry about all these emails. Then we use this to view it. So click on this plus box under the soundings folder, and you will see it right here with this little eyeball next to it. Double click that, and it'll jump right to it. So this step in the process is infinitely easier if you have a mouse. I am not using a mouse right now, so I'm going to struggle just a little bit but it's nothing you can't handle. Now, if you're in a big pond, a big, crazy, long, skinny pond with a bunch of fingers and little creeks running into it, like in northwest Oklahoma, it's going to be brutal doing this process, and it honestly would probably be faster to get a hold of someone with a mouse or to get a mouse. It's just such a pain in the butt. But on these South Texas ponds, they're usually, you know, pretty straightforward, and if it's a pit, it's even easier. So, but this isn't going to be any issue. So we've got this far. This is kind of what we saw on the top of the Sonar Vista, the top Sonar Vista window. Just a little easier to view here. What we want to do now is we want to check this data. We want to check the depth, because I know we saw that there was depth in Sonar Vista, but we couldn't really tell what it was or the quality of that data. So we right click on this weeks.xyz under the soundings folder, go to edit sounding, and you'll see a bunch of stuff that may or may not make sense. What you'll see over here is this record number. This is each individual piece of sounding data recorded. I'm going to click this and it's not going to work. This is the coordinates, and this is the depth. This is the row you really want to look at. If you click the depth, it'll go from ascending to descending order, and vice versa. So what we see here is the most shallow reading we got was 0.03 feet. The deepest data we collected was 6.53 feet. I believe that to be good data. That sounds about right. Just knowing that area, looking at the pictures Roy sent and his description, that seems to be accurate. Now you want to click on the show positions box and the show depths. And I like to turn off the track. That kind of clutters up our data. So I want to turn that off. You don't need to manipulate any of this here, as long as it's good. If you see zeros, you can delete that. Sometimes when you click this, you'll see something just way off the wall. So imagine that we had one here that's a negative 44 and a negative 19 and a negative 27. That is bad data. Let me show you how to delete that, because this one, fortunately for Roy, unfortunately for this tutorial, doesn't have any bad data. We'll pretend that this top point, data point 6978, let's say that's bad. You right click on it, remove track point. Okay, that's bad. That's what we're telling ourselves, remove it. If you have a whole bunch of bad data and it's obviously wrong, and you should know, you did the survey. If you was the pond you're in 50 feet deep? Was the pit you're in 30 feet deep? Probably not. So if you see a bunch of that bad data, go ahead and erase it. Sometimes it does that. I wish I had a good explanation for why we see it all the time. So if you got bad data, you can hold shift and push down. It's like multiple data points. We'll remove everything up to negative 6.07. And by the way, that negative just means below, the sounder. So don't mind that. It should be a negative. That's what it's supposed to be. So highlight those just like you would anything, and remove track points. Don't click remove all track points. That will literally remove every single track point. The one above it here, remove track points, just removes the ones you have highlighted. So we'll click that. Are you sure? Yeah, I'm sure. You see those are all gone. Now our max depth is negative 6.07. Now there's one step that we still need to make here in the edit sounding. Well, it's not in this, but it's under the soundings. We need to apply the offset. What the offset is compensating for the depth that the sounder is below the surface of the water. So the sounder at the front of the boat that hangs down and actually generates the sonar, the little ping, it's not flush with the surface. It hangs a little bit below. So basically it's not capturing those 3 or 4 inches above that between the sounder and the surface of the water. Well, we want to try to capture that the best we can. So the way you do that, go ahead and click OK here. Right click on the sounding file again and go to Shift Sounding. That's going to allow us to nudge that up, kind of simulate that would basically simulate the sounder being right there at the top of the water. And you want to click Apply Depth Correction. Come down here to the offset, and this is where you tell it how much. The standard that we use almost always is negative 0.33, or a third of a foot, which is, about 4 inches. That's pretty safe. Sometimes it's a little below, sometimes it's a little above, but that's a pretty safe, happy medium there. So that's almost always what we go to. If you're doing a survey and you know for sure that that thing was 6 inches below the water without, beyond a shadow of a doubt, then you can go ahead and go in there and put negative 0.5. And this is done in tenths of a foot, so, and hit OK. And you can go back in here and double check. I almost always go back in here and double check to make sure that that took. Hit the depth again twice to bring up the max depth, and you'll see that that just went from negative 6.07 to negative 6.4. So now it reads a third of a foot deeper than it did. That's exactly what we wanted it to do. All right, so click OK. Let's look at this data. This all looks pretty good. One problem is it's very monotone. That's unusual. That doesn't really help illustrate what we want to see here. So remember that the max depth that we have now after the offset is negative 6.4. What you want to do is change the color scale. If you look over here to the left, this is a huge color scale. We don't need that many colors in a 6-foot pond or a 7-foot pond. Typically, what's normal is to give each foot its own color. So really, there should only be 6 colors, and there's obviously more than that. So let me go back a little bit. I'm going too fast. Click on the Options tab, Matrix Colors. Click on this button here that says Auto. You want to leave this top drop-down box in all colors. Minimum depth. Now don't get this confused. It's asking for minimum depth, but really what we want to put is our max depth as a negative. So we want negative 7. It's already in there just because I did this one earlier, just to get it back to Roy. So minimum depth negative 7. So if the pond was 20 foot deep, you'd put negative 20. If it was 5 foot deep, you put negative 5. So on and so forth. This interval, basically that's asking, do you want to color every foot? Here, yeah, we do. Sometimes if it's a really big pond, I will give them more than one color per foot or really deep. But anyway, this works. Click reverse colors. The reverse colors doesn't really matter, but that's just how we do it. And then click OK. All right, now you can see a little bit of a gradient here. This is what you want. You can tell that this eastern border is the deep side. The edge is shallower, as you would imagine. And then over here, it's kind of weird. This western perimeter is kind of a green. You would expect it to be more of a yellow or orangish. But like we speculated earlier, I think this is where the trees are that Roy had problems with, and he couldn't really get back all the way around to capture that shallow perimeter data on that side. So we're about to see if that's the case. The next step, let's go to our maps. Right-click Maps. Download map. You want the source to be on Google Map Satellite. Click Calculate, and you got to tell it where you want it to calculate the map boundaries from. In this case, we want it to use this sounding file to generate the map. If you don't do this, you're going to get, there's no telling where it's going to take you. So click that. Make sure that this is in. This is almost always automatically in here. So nothing crazy there. Then it's going to ask you the output file. This is going to generate an image based upon the coordinates. So it's saying, what do you want to call it and where do you want to put it? So click on Browse. And this takes me to my Swift Weeks survey folder and ask for the name. If you do this right, if you're organized and you have a folder for every single survey you do, then you can just call the map. Otherwise, you'll need to give it a unique name. But I make a folder for every single one, so I just call them map. Click OK. This takes a minute, so let's just give it a second. Like I said, this is the quick and dirty version of the survey. If you were doing the report, you would go in and you'd make minute changes. You can kind of see in here. Can I move this? Some of this data is probably not perfect. You can see a little bit of green here, a little bit of orange here. This is not a perfect survey, but honestly, it is pretty good. If you were going to do a report, you'd go through and you would manually add data points. You would remove bad data points. This one honestly was pretty clean, And for this level of kind of cursory training tutorial, if it's not a clean survey, you probably don't need to be handling it just yet. But most surveys, you'll be able to make it just fine with what I'm showing you here. All right, the map is done. Let's click on the magnifying glass here and zoom in a little bit and see what this looks like. But speaking of cleaning up data, I showed you how to remove some bad data points in the edit sounding window. I'm going to show you how to remove some also from the map itself. Let's kind of hone in here on a spot that I think is probably bad. See this little red blip? That's probably not good data. Now, just because this little red blip is not good data, this would not change the outcome of your volume calculation very much at all. But I'm going to show you how to do it, because sometimes you'll see a bunch of these where they probably don't belong. This could have been vegetation under the boat. This could have been, I don't know, a giant turtle swimming underneath you. I don't know. It could be a lot of things, but it's obviously not good data. It's surrounded by all these solid data points. So we want to put the finger on it. You got to get in really close for this, and this is where it helps to have a mouse, but you can do it without it. Right click, remove sounding data, and it's gone. Simple as that. Now on the other end of the spectrum, let's add some data points, and actually here on this one we need to. Not required, but to get a little bit better volume, click the hand over here to move. If you don't have a mouse, you have to do it this way. Let me back up just a little bit more. We're going to add some data where these trees are. And I'm not going to go in and add 1,000 points like it would normally do. I just want to go in and add a little bit. I just want a little bit better idea of what we're looking at. So what I'm going to base this off of is I see, for the most part, we're looking at between 1.5 and 2.5, 3 feet, maybe 2 feet around the perimeter of the edge. I don't really see any reason to believe why this perimeter would be much different. So I'm going to go ahead and I'm going to find a spot, right click, add sounding data. This box is going to pop up. There's a lot of input boxes here, but all we want to do is add depth. So click on this depth here. It's kind of right in the center. Highlight that, and let's just say this. And we're kind of guessing, so a little creative liberty here, but this is better than nothing. So we're going to put -2. I think that's about -2, and you have to put the negative, otherwise it's going to read it way off. It's going to think that it's 2 feet higher than the sounder was, and we want to be 2 feet below. And you can see it added this little 2 feet mark. So I'm going to go in here. I'm going to add a couple real quick. Let's say -2.1. We'll add another one over here. Add shoreline data. -2.2. We'll get a little bit closer to the shore. Add sounding data. -2. Let's put one right up here. Add sounding data. -2.1. Now, whenever we run our matrix, which is going to be the next step here, it's probably going to connect these dots just fine on its own. But let's help it out a little bit. This is 3.5. This is 1/2. This looks pretty shallow here, but I think it's catching some of this vegetation. You can see it here in the map. So we're going to say that right around in here, this is probably about 3 feet. Add sounding data. -3. I'll put one more in here. This step is really not that necessary, but with such a large portion of this being blocked off, I figured let's give ourselves a fighting chance of getting close to the right volume here. Okay, it's not perfect, but it's an estimate, so it's not going to be. Whenever the engineers go in here and they really make this look perfect, they may fix a lot of this funky data on the outside. But you're about to see what it looks like with just the amount of work we've done. So next step is drawing the shoreline. So there's a little button right here you can do. Or you can right click this and put add. I like to just put this button. Oh, and there's also where's it at? Cursor. You can go to cursor and go to draw shoreline. I just click this little box right here. There's a few ways to do it. Important. This isn't the only way to do it. This is the way I do it, and if you do it this way, make sure you're following the steps. You need to do it in a clockwise direction, and just you are out there. I'm guessing where the shoreline is. based on the photos, kind of just based on where his survey paths are. Obviously with the boat, you're not going to get right on the edge, but you're going to get pretty close. So I have every reason to believe that the water line in this photo from the satellite matches pretty closely with where the water line actually was when he did the survey. So I'm just going to mimic that. If you're out there and you see, and you can obviously tell that the water is way higher or way lower than it is in the satellite image, because let's be honest, satellite image isn't always that accurate, uh, then adjust accordingly. And honestly, that's the best way to get an estimate volume. And when we send this off and the people who were running these shorelines weren't actually out there, it's really hard for them to capture all that data that you would being out there. So connect the dots, go around, left click, connect the dots. When you're back at the starting point, you right click. That's a step we forget a lot of times. Get back when you connect the dots all the way around. After going clockwise, right click, and then this edit shoreline box will pop up. It's going to ask you, what do you want to call it? Call it whatever you want. I never change that. And then this top box, water is right of shoreline. Shoreline is drawn CW around the water. That stands for clockwise. That's why it's important you do it that way. If you goof up and get here and you've done it counterclockwise, it's okay. Just check this box. The reason this is important is because sometimes there's little islands and stuff that you have to generate matrices and shorelines around objects. Not very common at all, but it does happen. But most of the time, this is going to be what you do. Then all you do is you click OK. Nothing happens. That's just the shoreline. But now that you have a boundary created and the survey data on the inside, you can go to the next step, which is the matrix. So right click on matrix, click on generate, and basically there's two components to a matrix: a sounding data file and a shoreline, or sounding data and shoreline data. And then it asks you, what do you want to use? It already shows it in here, but if it says none selected, just click it, and the only sounding data that's in this program or open at the time will be the only thing that pops up. So just hit OK. Shoreline data, it's not checked. Check it, hit OK. So you should see both little pieces right here. Depth, high frequency. We don't change the spacing, don't change the clipping area. And then once again, just like the map, it's going to ask you, where do you want to save this matrix? We want to save it in our folder. And like we named the map to map, I named the matrix to matrix because it has its own unique destination. And then click OK. This will take just a second, but not quite as long as the map. And this is what you see. This is kind of your bare bones survey report. Now it's not perfect. This is funky data. We could probably go in here and clean this up and remove some of these bad data points and input some guesstimated good ones. But it doesn't change it much on the surface area of this pond and on the differences in potential depths. It's really not gonna make a whole lot of difference. So we're pretty much here at this point. You want to save your project. Save project as, and this is going to save as a GMP, weeks.gmp. Hit enter. That way, if I screw up, I can come back and I can recalculate this volume real quick next time. The final step to doing this is go up here to your tools, and there is a button that says volume. There's two. One says volumes from sounding, one says volumes from matrix. We want the matrix. And then this pops up. It asks you what matrix you want to use. Sometimes you can do multiple matrices when you're testing, different data points if you need to erase or add. Usually you won't do that. So ask you what matrix, you tell it, and then all you do is you hit calculate down here, and you can see that it populates these boxes. And look at this totals right here in the middle. You want volume. You can see here, this is your volume. Now notice it's in cubic feet. There's one more step. Highlight and copy that, and let's bring up our web browser. Google is my preference, and let's paste that in there. 1192688 cubic feet. So you type that in, cubic feet, and we need to convert it. And luckily, Google will do that for us. You just have to tell it what to do. So cubic feet to oil barrels. Make sure you put oil barrels because there are differences in barrels. Hit enter, and here it is. That's it. 212,426 barrels. And that's pretty good. On a pond this size, you might knock off a few thousand barrels. Personally, I would tell the customer in this situation a rough estimate, a rough safe estimate would be 207,000 barrels. And when the report comes back, it will honestly probably be more than that, but they should be thrilled by that. It's always better to tell them a little less and be safe than tell them too much. Don't tell them what they want to hear. Tell them, tell them what is safe on our end. So that's it. If you have any more questions,